All right, let's talk about something that's absolutely critical for any developer on AWS, especially if you've got that DVA-CO2 exam on your radar, securing your APIs. We're going to break down the two main security guards you can hire for your API gateway: the super flexible, do-anything Lambda authorizer and the lightning-fast, built-in JWT authorizer. By the end of this, you'll know exactly which one to pick for any situation.
So picture this. You've built an amazing application. Your API is the front door to this exclusive club. You can't just let anyone wander in, right? You need a bouncer, a security guard at the door, checking IDs. And that's exactly what authorization is for your API. It's the process of deciding who gets the key before they ever get a chance to talk to your backend.
Okay, so here's our game plan. First, we'll establish why we need these security guards in the first place. Then we'll hit the first major fork in the road, choosing between a REST API and an HTTP API. After that, we'll do a deep dive on our two main contenders, the custom-coded Lambda authorizer and the speedy, native JWT authorizer. And we'll wrap up with the really important details: caching, policies, and a final review to make sure this all sticks for your exam.
So let's start at the beginning. Why do we even need to bother with this?
It's really important to get this straight. Authentication is about proving who you are. Authorization, though, is about what you're allowed to do. And by handling this check right at the front door, at the API gateway level, we stop unauthorized requests cold. They never even get to waste the time or money of our backend services. That's a huge win for security and your AWS bill.
Now, believe it or not, the very first choice you make when building your API on AWS really dictates your security options down the line. Are you going with the traditional, feature-packed REST API or a newer, leaner HTTP API? Think of it like this. REST APIs are the original workhorse. They're packed with all sorts of features, and they fully support those custom Lambda authorizers we talked about. HTTP APIs, on the other hand, are the newer, faster, and cheaper model. They're streamlined, and a huge part of that is a fantastic, built-in authorizer made specifically for the modern standard, JSON Web Tokens, or JWTs. This choice really sets the stage.
Okay, let's dig into the most powerful and flexible option you have: the Lambda authorizer. This is your completely programmable, custom-coded security guard.
And the way it works is actually pretty elegant. A client sends a request, API Gateway immediately stops it and calls your Authorizer Lambda function. Your code then runs whatever custom logic it needs to. Maybe it validates a token, checks a database, calls another service, you name it. Then it just returns a simple IAM policy that says allow or deny. API Gateway reads that policy and either opens the door or slams it shut. It's a really clean separation of your security logic from your business logic.
And here we go. This is a huge exam tip, so listen up. If you see a question that mentions any kind of custom, non-standard, or legacy authorization scheme, like validating an old OAuth 1.0 token or checking credentials against a proprietary database, the answer is Lambda Authorizer, every single time. The built-in options are for modern standards. For everything else, you need to write the code yourself.
Now, Lambda authorizers come in two main flavors, and this is a critical difference. A token-based authorizer is simple. It just looks at one thing, a token, usually from the authorization header. But a request-based authorizer is way more powerful. It gets the whole package: headers, query strings, path variables, the works. This lets you make decisions based on multiple parts of the request, which is essential for really fine-grained access control. Okay, so that's the custom-build security guard. Now let's look at the other side of the coin, the built-in specialists. These are managed authorizers designed to do one thing and do it extremely well: validate standard JWTs with maximum speed and zero fuss.
Here's another direct exam tip for you. If the question mentions a REST API and you're using Amazon Cognito for your users, the Cognito User Pool Authorizer is the answer. It is the easy button. You just point it at your user pool and it takes care of all the token validation for you. No custom code required. It just works.
And for HTTP APIs, it gets even better. Their built-in JWT authorizer isn't just for Cognito. It works with any provider that follows the OpenID Connect standard. So think Auth0, Okta, you name it. You just configure it with the provider's issuer URL and a couple of other details, and API Gateway handles all the heavy lifting of validation. Again, absolutely zero custom code.
So you might be thinking, well, why don't I just validate the JWT in my backend code? And you could, but using a managed authorizer is almost always the better choice. It offloads all that intense cryptographic work from your functions, it cuts down on latency because the check happens at the edge, and it makes you more secure by stopping bad requests before they ever touch your infrastructure. You're letting AWS handle all the complex stuff, and that's a win. All right, let's zoom in on some of the nitty-gritty details of Lambda Authorizers. This is exactly the kind of stuff that loves to show up as tricky exam questions.
Caching is your best friend for performance, but what does it cache on? Well, for a token authorizer, it's simple. The cache key is the token itself. But for a request authorizer, the key is a combination of all the different parts you told it to look at, maybe a specific header and a specific query string. This is really powerful because it means two requests with the exact same token can get different cached results if those other parts are different.
Now this is one of the coolest features. Your authorizer isn't just a gatekeeper, it can also be a helpful courier. In its response, it can include this context object with all sorts of useful data you looked up, the user's role, their organization, whatever. And that data gets passed directly to your backend Lambda. This saves your backend from having to make a whole separate call to a database to get that same info. It's so efficient.
And that IAM policy your authorizer returns, that's where the real power is. You don't just have to give a blanket allow. You can get incredibly specific. You can say, yes, you're allowed to use the get method on the /mydemo resource path, but you're absolutely denied from using post on that same path. You do this by specifying the exact method and resource ARN.
Here's a little gotcha that sometimes trips people up on the exam. How does API Gateway even get permission to call your Lambda authorizer in the first place? Well, it needs an IAM permission. Specifically, the action it needs is Lambda invoke function. You grant this permission to the API Gateway service, and the easiest way is with a resource-based policy that you attach directly to the authorizer function itself.
And finally, a simple but important fact you need to know for the exam. What happens when your authorizer returns a policy that says effect deny? API Gateway stops the request right there and sends back an HTTP 403 forbidden status code to the client. Plain and simple, you shall not pass.
Okay, that was a lot of detail, I know. So let's pull it all back together and boil it down into a simple decision matrix that you can use as a cheat sheet for the exam.
This right here is your guide. If you see a scenario with custom logic or legacy tokens, your brain should immediately scream Lambda Authorizer. If you see Cognito with a REST API, you go for the built-in Cognito Authorizer. If you're using any modern identity provider with an HTTP API, you use the native JWT Authorizer. And finally, if the decision needs to be based on more than just a single token, if you need to inspect multiple parts of the request, that's your cue to use a request-based Lambda Authorizer.
So that really brings us to the final question you should always ask yourself. When you hire that security guard for your API, what do you need them to do? Do you just need someone to quickly check a standard ID, like a JWT authorizer does? Or do you need a highly trained agent who has to understand the full context of every single person who walks up to the door, like a request-based Lambda authorizer? The answer to that question will always lead you to the right choice. Thanks for joining me.